test on Thursday and get that part done. Okay, now, we decided we're basic formula. X squared plus y squared equals 1 over. Fraction. So now, this is my a squared, my b squared. These are the guys that can change. The a is going to be the larger number. Is the larger number of between a and b. That's the major axis. And for those of you that weren't here, this is a good time to jump in because this way you start with ellipses, you'll be ready to take the test on Thursday, and then all you have to do is make up the parabola test. So we start like this, and we come over here. We had to build our equations, so we're given these points. The vertices, God bless you, the vertices sit on my major axis. The covertices sit on my minor axis. Remember I told you, exhaust one at a time. So I go to my vertices, and I plot my vertices here. That means my ellipse has to go this way. That's my major axis. Can you find the center from this? 0, 0. It's the average. Take the average of 0, the average of -4 and +4. My center is at 0, 0. And my major axis, so now I know I'm an x squared plus a y squared. Who gets the a, the y or the x? The y, because it's my major axis. So now, the distance from my center to my vertice is how long? 4. This point is 0, 4. This point is 0, 0. So a equals 4. So now I know this guy underneath here. All I need to do is find b. So now I've exhausted the vertices. I go to my covertices. -2, +2. They sit on my minor axis. The distance from my vertex, my center, to my covertex is 2. That's b. So now I just resolve this, and I write it out to make it look nice. Good? Okay. Work with this. Work with what you're given. All right. Next one. My vertices. Now, it's almost the same situation, but I'm on the opposite axis. So my vertices now are here. 3, 0 and -3, 0. That means my x-axis, my ellipse is going to go like this. So I start like this. Who gets the a, the x or the y?
And how do you know that?
Because my vertices lie on the major axis.
How do you know the major axis?
Because when we plotted this out, they're sitting right on which axis? What axis is that?
X.
X. So they're sitting right on the x-axis. If it makes a horizontal line anywhere, it's just an x, because I can also translate it. But these are sitting on the x, so I know a has to be x, b has to be y. Now, if they give me 2 vertices, that's the end point. That's the end point of my ellipse, right? Can I find the center? It's the average of those 2 points, right? The guy in the middle. So the average of the zeros is 0. The average of -3 and +3, 0. So there's my center. My center is at 0, 0. So A is the distance from the center to the vertex. You're just going to have to know these things. So A is how long? 3. So I'm going to put this with 3 squared. Now, I just need to know B. So they gave me, my foci. My foci are here and here at -2 and +2. So I know what my A is. My C I know is 2. My B I don't know. So I know this is 2 from here to here. I have to now use my c squared equals a squared minus b squared. But all you need to do is solve for b squared. So if my c squared is 4, my a squared is 9. Sorry, 9. So I subtract 9. So b squared is equal to 5. That's all I need to know is my b squared. I don't have to take the square root of it because then I have to square it when I come back here. So now I replace this guy with the 9, this guy with the 5. And there's my equation. Okay? We did a couple of more of these where we kept the 0, 0, just so that you get the hang of it. We did one example of this on Friday. It gave me my foci, so I know my foci has to be on my major axis. So my ellipse is going to go like this. So again, I start with x squared, y squared. I know under my x has to be my a because that's where my foci are. It's sitting on my major axis. So I can find my center, 0, 0. My distance from my foci to my, God bless you, the center is 5. But that still doesn't help me with my equation. So then I go look at whatever else they have. They have my major axis length. Which one is my major axis, my x or my y? X is 14. From this point all the way to that point is 14. So halfway from here to here is A. So what's A? 7. Use your diagram. Oh, now I have A and C. I can use my formula. I can find B squared. And again, all I need is B squared. I don't have to be fancy and find B. All I need is this guy. B squared equals 24. We need to know that formula to get there. Okay. This one was a tough one. This one gave me vertices of 0, 5 and 0, negative 5. So it's sitting on which axis, my x or my y? Y. So that one's going to get the a squared. And again, your center is halfway in the middle. So your center's at what? 0, 0. So I start out like this. X squared plus y squared. There's my a. The distance from here to here, 5. I square it. Now, I'm right here. This is as far as I can go. 5 squared is 25. But I don't know anything else about this. So I go to my next piece of information. It passes through the point 4, 2. So somewhere 4, 2 is my point on my ellipse. Okay, but it doesn't give me my foci. It doesn't give me my minor axis, but it does give me my x and y. So what we can do at this point is say, okay, just like we did with your parabola when we had something that passed through it, this is your x, this is your y. Wherever you see x, put a 4. Wherever you see y, put a 2. So this is going to give me 4 squared is 16 over b squared plus 2 squared is 4. Okay, now, the easiest way to do this, and there's a number of ways to do this. You can multiply everybody by 25b squared, or a little easier is this. This is your b squared. I need to solve for b, right? So I'm going to get rid of this guy. So I'm going to subtract this from both sides. So I get 16 over b squared. And I don't know what the heck this is, but I have a nice little calculator. So if I didn't want to convert my denominators, I could easily put it in my calculator and flip it back to a fraction, can I? And get 21 over 25. And now how can I solve for b squared? What can I do here? I have a proportion, a ratio. Cross multiply. I can do 16 times 25 equals 21 times b squared. Divide both sides by 21. I can come up with b squared. And b squared is going to be 400 over 21. Does it help me? Not really, but I don't really care what it looks like. Like if I have to take this, does it help me to take the square root? No, it doesn't help me. And I don't really care what it looks like. All I care about is my b squared. I gotta put that right here. So when I do this, 16 over 400 over 21 plus 4 over 25. Sorry, this is my x squared, my y squared. I'm good now because that's going to be my b squared. That's my major, my y-axis. But this guy right here, I don't really like to leave a fraction in my denominator. So if I keep, change, flip, it causes this guy to flip up here. It's not that it's not doable. It's doable. You just have to walk through the steps with fractions. Your rule of thumb is you can never leave a fraction in a denominator. You can never leave a radical in a denominator. We let you leave radicals in your denominators in pre-calc, but we still don't let you leave fractions in your denominators. So we're just going to have to use our rule, keep, change, flip, and flip that over. If you at least got this far, that makes me happy. Okay, you should be able to solve for b squared. No, but I do need you to know how to do it. A lot of times when we get down here, this is just algebra. This has nothing to do with your ellipse. This is just algebra. You need to be able to not panic over this and walk through the steps. Okay, now we offset your your ellipse. We offset this a little bit. And how do I know it's offset? Because look where my vertices are. My vertices are 2, 6, 2, 0. So I go like this. My ellipse has to go like this somewhere. Hopefully land on the 2, 0. So my ellipse has to go like this. This is my major axis. My center still comes out in the middle. My center is the average, the middle. To find somebody in the middle, you add them together, divide by 2. Add these together, divide by 2, I get a 2. Add these together, divide by 2, I get a 3. So now my distance from here to here is 3. That's A. So this is what I'm looking at. My center and the distance from here to here is 3. That's A. So I can start with my center that I just found out. This is my H and K. And my y squared has to say my A. This has to be my B. And my covertices are kind of nice for this. It kind of also tells me where my center could be. 2, 3, 1, 3. Oh, look at that. I'm sorry. 3, 3, 1, 3. 2, 3 is smack in the center of that, isn't it? And my B is 1.
Why does that equation look different from the other ones? Like, why does it have
Because look where your center is. Your center is not at the 0, 0. It's translated. So therefore, we had to find your center just like we found your center before. But now, instead of this, we have to expand this. H, y minus k.
So whenever it's not 0, 0, you can do that.
Yeah. Same thing you did with your parabola when it was offset, when it wasn't at the 0, 0. And that wasn't a bad one either. Okay. Couple more. Vertices at 0, 2, and 8, 0. So that tells me who's the major axis, the x or the y. It's going sideways like this. X, good. So the x gets the a squared. That's what this tells me. X gets the a squared. Can you find the center between these guys? Average. 8 plus 0 divided by 2, 4. 2 plus 2 divided by 2, 2. There's 4 and 2. Perfect. There's my x minus 4, y minus 2. The distance from 4, 2 to 8, 2 is 4. That's A. The minor axis length is 2. That means this whole thing right here is 2. So cut it in half, and B is 1. All I needed was B. I didn't care about anything else. I found A after I found my center. So you start with your vertices. Your vertices are 0, 2, and 8, 2. That means this is your vertice. Your ellipse has to go like this, right? So that means it came horizontally, it came from an x-axis. So right away I know my x squared has to get my a squared. I can start like this. I need my center because, oh, it's not at the 0, 0, so I take an average. Average of 8 plus 0 divided by 2, 4, 2. So now I know my h, my k. So I can change this to say x minus 4 squared, y minus 2 squared. Now I can find the distance from here to here. This is a. A is 4. There's 4 squared. And all I have left to do is find b squared. Always start with your basics because I find it easier. You know exactly what you need left. Oh, and they gave me this little piece of information. The length of my minor axis, this whole thing, is 2. So if I cut it in half, I find b, and b is 1. So now I can rewrite exactly what I have, make it look pretty. And it has to be equal to 1, don't forget.
A is the distance between the center and the vertices, and then B is what?
The distance from the center to the co-vertices. Your minor axis.
Is the same as the foci?
Nope, your foci is on your major axis. You know that page of notes? Look those over. Okay, and this one kind of similar. You have your foci first. Foci is C. And we don't care about what b squared is. What b is, we just care about what b squared is. Okay. And then the last one, I think we have one more. Two more. Vertices, which tells me that's my major. And your minor axis, this is just like the other one. See if you can do those. This one's a little tougher down here. Once I find A, I can find A because of this right here. At negative 4, 4, at positive 4, 4, I can find my center. And I know the distance here is A. Well, if this is A, now I can find out C. Then from C, I can find out B. C doesn't affect my equation, but C is a means to get there if I use C squared equals A squared minus B squared. So if they give you a foci, you can still get to either the A or the B from your foci. Okay, so look those over. It makes a difference which one comes first. I can subtract 5 minus 3. My answer is 2. But if I subtract 3 minus 5, is my answer still 2? No. So this is not commutative property when you subtract. So therefore, in a hyperbola, you are going to see a subtract, not an add. And because we can't change positions like x squared and y squared with the ellipse, we say the major axis comes first. So notice this guy, this is the y. If we want the y to be the major axis, it's going to come first. If you want the x to be the major axis, it's going to come first. So under the first term is always your a squared. It does not matter who's larger. Because in the subtract, it matters who comes first. Try to remember that. Now again, we still have a center. We still have your center of your hyperbola. We still have vertices, but I put these little asterisks by your co-vertices. Technically, your co-vertices don't exist, but we need them to graph your hyperbola. But they do not sit on your hyperbola. The one difference is this guy here, c squared equals a squared plus b squared. And I'll explain that in a minute, why we use a plus and not a minus. And then the only other weird thing you might notice is an asymptote equation. And we'll talk about your asymptote equation when we get there. So again, In this one, because it's a subtract, same kind of setup, but the x and the y squares will change position. The a squared will always be first. So let's see if we can try one and see what the heck is she talking about. Now, again, you'll see an x squared and y squared. So let's complete the square for these guys. Let's get our x squareds together and get the constant to the other side. What I did notice, I converted your parabola test. Some of you, what happens when you put them to the other side? Forget to take the opposites. I know I arrow over, but this means subtract 16 from both sides. Some of you aren't changing the signs when you move them to the opposite side. But just because I arrow over, I change my sign. You might have to just do it out the long way. Now, I notice my x's. I'm going to have to group these guys. And my y, my y squared over here, doesn't look like I have anything to complete the square for. I have no other y term, right? So all I have is an x squared. So what can I factor out of my x terms? I need this to be a 1. 4. This is where I'm going to complete the square. My y, I'm going to have to worry about completing the square. So because I added once on this side, I'm going to add once on the right side. What's half of 2? 1. What's 1 squared? 1. Now I got to get this out, so I got to multiply it by 4. So I'm going to add 4 over here. I'm going to bring this 4 down here because it's a factor. So that guy's good. If I actually multiplied this out, this would give me the inside one. When I distributed it, it would give me this guy. Minus 3y squared, I don't have to do that one. And this gives me negative 12. Now, with an ellipse, everything was positive. But with a hyperbola, one of them is negative, because it's a subtract in the middle. So I need this to equal 1. So I'm going to divide everybody by a negative 12. Now notice what happens to these terms. The first term is becoming negative. The second term is becoming what? Positive. So I'm going to rewrite my positive term first. This is going to go in here 4 times. This is going to go in here 3 times. My negative term is coming second. There's the equation of my hyperbola. My a squared is first. This is my b squared. So what's a? Square root of a. 2. What's b? Square root of 3. Now, c squared is c squared equals a squared plus b squared. 4 plus 3. So c is equal to radical 7. And that's okay, I'll deal with the radical 7 in a minute. So again, we're going to sketch. The sketch is a little bit different. So what's the center of this hyperbola? Negative 1, 0. Good. Everybody get the negative 1, 0? It comes out the opposite way. This one doesn't have it. It's like y minus 0 squared. And my major axis is the one that comes first, the y. That means when I graph this, my hyperbola has to come off the y. It's going to open up and down. So I'm going to take my center, negative 1, 0. I'm going to make like a translated axis just because that just usually helps me out. My major one is the y. I'm going to go up 2, down 2. Oops. So what's my vertex at? If I'm at the 0, negative 1, I'm sorry. I'm at the negative 1, 0, and I move up 2. What will I be at? Good. If I move down 2, what will I be at? Good. Okay, we didn't need any formulas, right? Now my co-vertices says, you technically don't exist, but I need you to make this, I need you to help me do this, to make my hyperbola here. So I'm going to move radical 3. Radical 3 is about 1.7. It's a little bit more than 2, a little bit less than radical 4, which is 2, and more than radical 1. So I'm at the -1. I'm going to have to go here and here. I don't really have to keep track of those vertices, but I need to mark them off. From that, instead of making an ellipse, this is what's different. I make a rectangle. Before I made an ellipse. My co-vertices and my vertices made me an ellipse. Now I make a rectangle. And I make these arrows that go through the corners. These are called my asymptotes. Now to make my hyperbola, it goes off the one that comes first. In this case, y is first. So I start at my vertice. It's just like a little parabola. And I open up like this. I use my asymptote as a guideline. You know how you found your intercepts with your parabola? And that would tell you how wide you are? We don't need to do that with this because we have these little guidelines that we stay within. If the diagonals come out really wide, then my parabolas are two little wide ones. Notice I don't use my co-vertices at all. Now, because this is just like a parabola, where did your foci fall with your parabola? Inside. So somewhere in here is going to be my foci, which is why we add that together rather than subtract that. So since it's radical 7, I don't have to add or subtract. I could just take this. Notice my y is changing. So I'm at -1 plus or minus radical 7. That'll get me this one and this one. Because there's nothing I can resolve with my radical 7. Question?
Going back to the equation, how did you get -16 plus 4?
Okay, so we factored out a 4 because this had to be a 1. So that gave me a 2 over here. So we took half of 2, which is 1. 1 squared 1. Now I can't get this out of the parentheses until I distribute this. So 4 times 1 gives me 4. My -16 came because this guy has to go over there. So I subtract my 16. Now that's okay if that's negative, because notice the hyperbola has a subtract in the middle. When this term was my negative term, but when I divided a negative by a negative, that term became my positive one. This one became my negative one. Okay? Now, question? No, because what happens on this one, the ellipse says, put it inside my ellipse. My hyperbola says, put it outside of this. So rather than subtracting them and coming inside, we're adding them so that we go outside. They have to come out of this box. So that is one of our key differences. An ellipse would say, subtract it, you'll be in here. And there would be my ellipse, right? A hyperbola says, add them so that you'll be outside of that box. Okay? Now I need to get my asymptotes. Now, easiest way. An asymptote is a line. Y equals mx plus b. So watch up here a second. There's no squared in this. But whatever y happens to be, y minus 0, y plus 2 squared, y minus 7 squared, I put that right here. So technically y minus 0. I'm just going to put y minus 0 for now. I need my slope, and I need my x, which is x plus 1. My b, we'll work out my b in a minute. Now, this is how I want you to start. Your slope is your change in y over your change in x. Isn't that the slope of a line? Change in y over change in x. So, this is what I want you to do. Come to your y, come underneath your y, and take the square root of whatever's there. So what's the square root of 4? 2. From underneath your x, take the square root of whatever's here. Radical 3. That's your slope. And we say, because we've got two lines, we say plus or minus that slope. Now, all we have to do is clean this up. Whatever is over here, I'm just going to add or subtract to the other side. So in the case of 0, do I have to do anything? So y equals plus or minus, there's your slope, x plus 1. This is a plus sign, sorry. X plus 1. Now, the good part is, you can leave it like that. If I had to distribute that, then collect my like terms, I'd have to do it 2 separate times and make a b. I don't need to do that. That's how you're going to give me your equation of your asymptotes. Your equations are pretty straightforward. Let me just backtrack this 1 second to where this was. See these equations right here? Y minus k, whatever your y minus k is, whatever your x minus h is. The square root of the y denominator over the square root of the x denominator. That's your slope. Square root of y, change of y over change in x, but in this case, whatever's under the y, take the square root. Whatever's under the x, take the square root. So does that make sense? Okay. Good? Let's see if we can try the other one. Oh, was that it? That was it. Okay. All right. So you guys are going to try these for homework. Do you want to get one started? Now, how do I know this is a hyperbola? With the minus. Good. If it was a plus, what would it be? Ellipse. Now it matters who comes first. So who gets the a? The x. A squared, b squared. You still need to find a equals, b equals, c equals. And you're going to use c squared equals a squared plus b squared. What's the center of my hyperbola? 1, negative 2. Good. Okay, my major axis is which one? X. It's the one that comes first. So therefore my hyperbola is going to go like this. Somewhere along my x, or translated x, whatever I have. So I start with my axes. I make my center. My center is at 1, negative 2. Translate this. Just move this over. Okay? What letters do I know here? A and B. What's A? What's B? So I can certainly find C. C squared equals 4 plus 1. C squared equals 5. So C equals radical 5. Okay, and now watch. Radical 5 is bigger than radical 4, right? So it's larger than 2. So doesn't it push me out of A's range there? I got to get out of this box. I got to get away from that little thing there. Okay, so let's see what we've got. So from this point, we said x is your major. God bless you. So x is going to go over 2 and over 2. This is a vertex. This is where your hyperbola is going off of. So using the point 1, negative 2, which is going to change when I move right and left. The x, isn't it? So if I take 1 and I add 2, what do I get? 3, negative 2. If I take 1 and I subtract 2, what do I get? Negative 1, negative 2. There's my vertices. My co-vertices I just need to keep track of because I need to make that box. So my co-vertice says B is 1. So if I move up 1, down 1. I don't really have to keep track of those, but if you wanted to, this is at the 0, negative, this is, sorry, at the 1, 0, and at the 1, negative, oops, wait a minute. 1, negative 1, sorry, it's closer. Sorry, it's over here. So now, make your rectangle. my hyperbola is going to come off this V, but my box is going to help me see how wide this is. So through the corners, make your diagonals. Now your hyperbola goes off like this. See it? It's kind of narrow. No intercepts, just a guideline. Your foci are going to sit in here. So your foci are going to come off the center, which was 1, -2. It's going to be radical 5 away. Am I changing the x or the y when I go horizontally? So all I need to do is this: 1 plus or minus radical 5, comma -2. That's my foci. I can't resolve radical 5, so I can leave it like that. Now my asymptote says take the y plus 2. Here's my plus or minus. We're going to do your slope in a second. Take the x minus 1. Now slope is changing y. What's under the y? Square root of that.
And it goes to
Wait, under the y.
under
1. Under the x, square root under the x, 2. So I'm almost there. Doesn't my line have to say y equal? Just subtract the 2 from both sides. Y equals -2 plus or minus 1/2 x minus 1. That's everything I need to know about my hyperbola. Okay? And if you want to divide this out, you can figure that out. Yes.
When will we